In physics, the electron volt is a unit of energy equal to approximately 160 zeptojoules or 69811600000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 definition, it is the amount of energy gained by the charge of a single electron moved across an electric potential difference of 1 volt. Thus, it is 1 volt multiplied by the elementary charge times 10⁻19 C. Therefore, 1 electron volt is equal to 6981160217620799991.60217662008 times 10⁻19 J. Historically, the electron volt was devised as a standard unit of measure through its usefulness in electrostatic particle accelerator sciences because a particle with charge q has an energy E equals qv after passing through the potential V, if q is quoted in integer units of the elementary charge and the terminal bias in volts. One gets an energy in eV. The electron volt is not an SI unit, and its definition is empirical, thus its value in SI units must be obtained experimentally. Like the elementary charge on which it is based, it is not an independent quantity but is equal to 1 c square root 2 h alpha, mu 0 c 0. It is a common unit of energy within physics, widely used in solid-state, atomic, nuclear, and particle physics. It is commonly used with the metric prefixes milli, kilo, mega, giga, tera, peta or exa. Thus MeV stands for milli-electron-volt. In some older documents, and in the name Bevatron, the symbol BeV is used, which stands for billion electron volts. It is equivalent to the GeV. Mass. By mass energy equivalence, the electron volt is also a unit of mass. It is common in particle physics, where units of mass and energy are often interchanged, to express mass in units of eV, c2, where c is the speed of light in vacuum. It is common to simply express mass in terms of eV as a unit of mass, effectively using a system of natural units with c set to 1. The mass equivalent of 7001000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000each with the mass of 0.511 MeV, can annihilate to yield 698716374243697140001.022 MeV of energy. The proton has a mass of 699993800000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000w of 700100000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000wwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwww mass for particle physics. 700100000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000wwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwwww 1.783 times 10⁻27 kilogram. The atomic mass unit, 1 gram divided by Avogadro's number, is almost the mass of a hydrogen atom, which is mostly the mass of the proton. To convert to megaelectronvolts, use the formula 1 atomic mass unit equals 70029314000000931.4941 MeV. C2 equals 69999314941000000009314941 GeV. C2. Momentum. In high-energy physics, the electron volt is often used as a unit of momentum. A potential difference of 1 volt causes an electron to gain an amount of energy. This gives rise to usage of EV as units of momentum, for the energy supplied results in acceleration of the particle. The dimensions of momentum units are Lmt-1. The dimensions of energy units are L2mt-2. Then, dividing the units of energy by a fundamental constant that has units of velocity facilitates the required conversion of using energy units to describe momentum. In the field of high-energy particle physics, the fundamental velocity unit is the speed of light in vacuum c. Thus, dividing energy in EV by the speed of light, one can describe the momentum of an electron in units of EV c. For example, if the momentum p of an electron is said to be 6990160217648700001 GeV, then the conversion to mks can be achieved by distance. In particle physics, a system of natural units, in which the speed of light in vacuum c and the reduced Planck constant h are dimensionless and equal to unity is widely used. C equals h equals 1. In these units, both distances and times are expressed in inverse energy units. In particular, particle scattering lengths are often presented in units of inverse particle masses. Outside this system of units, the conversion factors between electronvolt, second, and nanometer are the following. The above relations also allow expressing the mean lifetime tau of an unstable particle in terms of its decay width gamma via gamma equals h tau. For example, the BO meson has a lifetime of 1.530 picoseconds. Mean decay length is c tau equals 69964596999999999999999999999 micrometers, or a decay width of 6977689256324707400 times 10⁻⁴ electron volts. Conversely, the tiny meson mass differences responsible for meson oscillations are often expressed in the more convenient inverse picoseconds. Temperature. In certain fields, such as plasma physics, it is convenient to use the electron volt as a unit of temperature. The conversion to the Kelvin scale is defined by using Kb, the Boltzmann constant. For example, a typical magnetic confinement diffusion plasma is 698524032647304999915 keV, or 170 megakelvin. As an approximation, kBt is about 6979405441217500000.025 electron volts at a temperature of 70022931500000000 20 degrees Celsius. Properties. The energy E, frequency V, and wavelength lambda of a photon are related by where h is the Planck constant, c is the speed of light. This reduces to a photon with a wavelength of 69935320000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 1 infrared photon of wavelength 6994124000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000ℎ THz. Scattering experiments. In a low-energy nuclear scattering experiment, it is conventional to refer to the nuclear recoil energy in units of EVR, keVR, etc. This distinguishes the nuclear recoil energy from the electron equivalent recoil energy measured by scintillation light. For example, the yield of a phototube is measured in phi, keV. The relationship between EVR and EV depends on the medium the scattering takes place in, and must be established empirically for each material. Energy comparisons. 701384114265567500005.25 times 1032 electron volts. Total energy released from a 20 knots nuclear fission device. 700919546553141400001.22 times 1028 electron volts. The energy at the Planck scale. 7006160217648700001 times 1025 electron volts. The approximate ground unification energy. 624 eV. Energy consumed by a single 100-watt light bulb in 1 second. 300 eV. The so-called oh my god particle. 6996320435297400002 PeV. 2 peta-electronvolts, the most high-energetic neutrino detected by the IceCube neutrino telescope in Antarctica. 699422430470818000014 TeV. The designed proton collision energy at the Large Hadron Collider. 6993160217648700001 TeV. A trillion electron volts, or 699316020000001.602 times 10⁻⁷ J, about the kinetic energy of a flying mosquito. 125.1 plus or minus 0.2 GeV. The energy corresponding to the mass of the Higgs boson, as measured by 2 separate detectors at the LHC to a certainty better than 5 sigma. 69893364570622700000210 MeV. The average energy released in fission of 1 Pu 239 atom. 698932043529740000200 MeV. The average energy released in nuclear fission of 1 U 235 atom. 698828198306171200017.6 MeV. The average energy released in the fusion of deuterium and tritium to form He4. This is 70144100000000000000041 petajoules per kilogram of product produced. 698716021764870000001 MeV. About twice the rest energy of an electron. 698221789600223200013.6 electron volts. The energy required to ionize atomic hydrogen. Molecular bond energies are on the order of 6981160217648700001 electron volt to 6982160217648700010 electron volts per bond. 698125634823792000001.6 electron volts to 698154474000055800003.4 electron volts. The photon energy of visible light. 697940544121749999925 MeV. The thermal energy kBT at room temperature, 1 air molecule, has an average kinetic energy 697960827065059999938 MeV. 697736850592010000230 microeV. The thermal energy kBT of the cosmic microwave background.